about using land surface temperature as a proxy for air temperature in urban setting.
Wonderful. Is this mic working like this? If this works, perfect. Yes, I have the honor to add on to the realm of talks around the land surface temperature, air temperature discussion here. My name is Lukas. I'm part of the 3D Geoinformation Group at TU Delft and also AMS Institute in Amsterdam. For those of you who don't know, AMS Institute is more focused on action-based or research, on really bringing research into practice. So this is what I'm also focusing on. A little bit of a disclaimer, what I'm presenting is still pretty preliminary and basic. I've been given a bit of a time frame to figure out what I want to do for a potential PhD, and I've been dabbling in a lot of different things. So yeah. And I really come here with more questions than answers. So I'd really love your input, your feedback, and also to figure out if I should proceed with this, and if so, how. So let's start with some results and the status quo. So what I've got is almost 10 years of weather station data in Amsterdam and Rotterdam, and 10 years of Landsat information. And as you can see in this time series, we've got a pretty good overlap between the two. LST in blue, air temperature in yellow, what we would actually expect. So this is based on 150 Landsat scenes, 33 weather stations in Amsterdam and in Rotterdam, as you can see on the screen here, which brings me to about 2,100 comparison records. It's not tremendous amounts of data, but it is a start where we can start seeing some results and do some comparisons. All I do is code-based and hopefully reproducible and expandable. Yeah, but you can already see one of the problems here is that Landsat obviously has a big recurrence time, so we don't really get a lot of cloud-free observations for each year. So this is in 2015, I think we had about 10 observations, 10 useful scenes for 2015. Overall relationship is pretty good, as we would probably expect. Yeah, for every degree increase in land surface temperature, we see about a 0.6 degree increase in air temperature. It gets a bit fuzzier when you look at this in terms of seasons. This, I think, is probably one of the biggest problems that I've been facing, is that, yeah, the season that we're interested in most, summer, is where it gets really, really fuzzy, and we see a sort of a decoupling of land surface temperature and air temperature in that relationship. I wasn't aware of the work around TC Chakraborty and Zander Venter before I came here, so this was great to already get to know a bit of work around this. They've already documented this in quite great detail. So I don't know if you're in the room, but yeah, I'd love to have a little chat. But how do we get here in the first place? So I was essentially tasked to figure out if we can derive the impact of urban morphology on environmental phenomena. So we've got a plethora of... Oh, I didn't know there was sun. That's great. Can I mute this? Yes. So we've got a plethora of data sets in the Netherlands. We've got, from our research group, a whole 3D building data set for the entire country, which is automatically generated. We've also got plenty of good resources. So we've got a great Python library for morphological analysis from MoPy. We've got global data sets, the GBMI, the Global Building Morphology Indicators data set. And we also did some work in the group on specifically 3D-defined proper 3D morphology indicators. So what we don't have is climate information. So this is where I sort of struggled for the first bit. So we've got great tools and data sets, but we don't really have the climate data. And I thought, okay, I've worked with LST before. Let me try and close this gap that we're seeing. This is not very novel. So why bother? Yeah, a lot of the previous research has been, well, at more lower resolutions. So a lot of work has been done with MODIS. Not a lot of work has been done with Landsat. And yeah, so previous statements were more along the lines of it's presently unlikely that a simple statistical model could be obtained between land surface temperature and air temperature at the city scale, which I agree if you're looking at a kilometer resolution. But a lot of the previous studies also for Landsat have had very few stations or very few Landsat scenes that they've used for the comparison. So I thought, okay, I can add to that. I've got 10 years of weather station data, 10 years of Landsat. Let's try what we can get with this. So I've been busy building a prediction model, or like that's something that's in the works. I've got a whole plethora of morphology indicators that I want to test to improve the relationship. So building level indicators, building height, for example, there's a whole list here. Street canyon indicators like the height to width ratio or the orientation of the streets, and a lot of different urban fabric indicators. So this is taken from a just recently defended doctoral thesis from Daniela Marilari, a colleague of mine at TU Delft. Highly recommend you read this. Very, very interesting work. Yeah, I've got sort of the pipeline ready for this, and I've been busy computing some of these indicators around the stations. Some first experiments with sort of trying to figure out what is the feature importance of these different indicators. So what you see is that, well, land surface temperature is clearly the biggest sort of predictor that we see here, or the biggest influence. And I don't really see a lot of other values or other indicators so far having a massive impact. So building height has got a bit of an indicator here, and then the shed wall ratio, for example, more like a density indicator. What puzzled me was that the local climate zone did not really have big impact. So I don't know if anybody can explain this to me. Yeah, confused me a little bit. We can build a basic prediction model from this, and results are okay-ish. I mean, we're getting around like errors around 2 degrees, 2.5 degrees for the overall model. So what I'm planning to do with this is, well, I've got a year of data to add still, and we've now got the twin satellite. We've now got Landsat 9, so we've got a few more scenes, which I'm hoping to integrate for the last year. Compute the indicators at different scales around the station. So the elliptic version, I think that's quite an interesting one as well. Compute them at a combination of scales and work with those indicators at a combination of scales to maybe see if that makes a bit of a difference, and then add other metrics. I mean, you see this was very preliminary working with averages, not very useful maybe, but yeah, and then I want to compute and test more indicators. The issue here is replicability. I really want this to be useful in other places, so we've got plenty of data in the Netherlands, not really reproducible everywhere. But that brings me to, yeah, I think the biggest caveat on what I'm struggling with the most, and that's the uses and applications. The context that I'm working in is very flat and in multiple ways. So the Netherlands are flat in general, topographically speaking, but we're also mainly working with low-rise environments and low-rise urban spaces. So there you will expect a better relationship between land surface temperature and the canopy layer air temperature. But I was painfully reminded on my way here, I stopped over in Singapore, that this is not the case everywhere in the world. Sometimes you need to be hit in the face with that realization. And yeah, so this actually something that is usable is a big question that I have. And then the question of errors, like what kind of an error is a good error, and when is a model actually usable? So if we have around a 2-degree error from a prediction model, plus then we have uncertainty from the land surface temperature product itself, what do we then actually do with this information? Yeah, big questions that I'm hoping to have a conversation about with you guys. And I've already had a few in the past few days. So where do I go from here? As I said, I've dabbled in a few different other things. I started with this lack of observation data, and I've been really interested in another angle on this. And that is more around sensing equity. There's an interesting project from the UK, from Newcastle University, around Rachel Franklin, who's been working on sensor coverage of populations specifically. So that's also something that I've been working with, extending this into the Dutch context. It was very UK specific, so I've been adapting the code base. What you see here is the network of air quality stations in Amsterdam with those little dots, and then the bars are the population density. And as you can see, where the sensors are and where we sense information is not necessarily always where the people are and where this pollution, air pollution or heat is experienced. So what she's been working on and what I've been adapting is essentially optimization algorithms to see, okay, how can we, for different objectives, optimize the coverage of populations by certain sensors and sensor networks, and essentially asking the questions, how do we deploy sensors in the first place? Is there a way to maybe do this in a bit more reproducible fashion? That's the first thing. And I've also, well, very recently started with Sensible. So the Sensible City Lab's got a satellite lab in Amsterdam, and I'm going to be working with them to deploy mobile sensors to get a bit more spatial coverage. So they've got the city scanner, the mobile environmental sensing platform, and we're going to do a first deployment of that in Amsterdam, hopefully over the coming months, to try and fill those gaps in maybe a different way to land surface temperature, but maybe also to add the data that we collect with these kind of sensors to this comparison. Yeah, and that is my story for now. Thank you for listening. And as it says, any thoughts, comments are appreciated. If this sparked your interest, please let me know, connect.
Thank you, Lukas, for your great talk. Time to questions.